Optimization Problems Part 3. Today I'm going to do an example of the shortest distance. We're going to do how to minimize the time to an outhouse, very exciting, and how to minimize the cost of laying a cable from an island to the mainland. So let's start back here with the sailing ship. Don't forget to subscribe. A sailing ship is 25 kilometers due north of a derelict vessel. Okay, so a derelict vessel is just one that isn't operational anymore. If the sailing ship sails south at 4 kilometers per hour and the derelict vessel drifts east at 3 kilometers an hour, find the closest approach of the two vessels. Okay, so here's our derelict vessel here. Here's our sailing ship because it's got a sail on it. And this one is 25 kilometers north of this one. So this ship is sailing south and this ship is going east. So this one is going in this direction, and we know that it's going east at 3 kilometers per hour. Now, this ship here, the distance as it comes closer and closer in the straight line, because it's sailing due south at 4 kilometers an hour. If I asked you, where is the ship going to be after 1 hour, you'd say, well, it went 4 kilometers, so it would be 21. And after 2 hours, it would be at 17. And after 3 hours, it would be at 13. Right? So you're subtracting 4 every time. So this distance actually becomes 25 minus 4t, where t is the number of hours that have passed. So when we start, we're right here, right? That's how far apart they are, 25 kilometers. But as this one comes down, this one is going slower than this one. So this one might have come down, let's say, 1/4 of an inch, but this one only went that far. And then as we get closer and closer, as this one comes closer to where the derelict vessel was, we're changing the length of this line here. So if the boat was here now, for instance, the distance would be here. So you can see that the distance is going to be the hypotenuse of a triangle. And so all we need to figure out is how far this one is and how far this one is, and we can figure out the distance. So the distance between them is just using Pythagorean theorem. So this distance here is going to be 25 minus 4t, 25 minus 4t, and of course it's going to be squared, plus, and this distance here, so it's going 3 kilometers every hour. So this distance is going to be 3 times the number of hours, t. So 3t and 25 minus 4t. So this is going to be, don't forget to put this in brackets because you want to make sure you square that 3 as well. Okay, so if I expand this question now, 25 squared is 625. Twice the product of these two is minus 100, so I have minus 200t plus 16t squared plus 3t squared is 3t squared is 9t squared. And if I write that in descending order, so I have 25t squared minus 200t plus 625. Okay, so now I have an equation for the distance, or formula for the distance between the two ships at any time t. And if I want to know the closest approach, again, I want to take the derivative. So the problem here is that I have d squared on this side. So there's two approaches to doing this, and I'm going to show you why both of them still apply. If I take the derivative of this without taking the square root, I can write this. I'll take the derivative of d squared, so that's 2d, and the derivative with respect to time. So I'm basically taking the derivative of this on the left side, and then I'm going to take the derivative of this, and I'm going to say the derivative with respect to time is going to be 50t minus 200 divided by 2d. Now, as you know, when I go to find the critical values, and I'm going to say for critical values, set dt equal to 0, or I could have called it d prime, 2d d prime. I only need to know what makes the numerator 0, and of course that would be very easy to solve. 50t is equal to 200, so t is equal to 4. So that means they're going to be the closest after 4 hours. Now let's go back here and just do it the way that maybe you might be a little more familiar with, and that is to take the square root of this one. So I could go from here and say that d is now going to be equal to, and I'm just going to write it with the half exponent to save a little bit of time here. So if I write that to the half power, and now I take the derivative, so I'll say d prime, that would give me 1/2 25t squared minus 200t plus 625 to the minus 1/2 and the derivative of the inside, don't forget. So that's going to be 50t minus 200. And I think you can see right away that that's the same number that is here. And if I simplify this or just straighten it out a bit here, I would have 50t minus 200. And in the denominator, I have the 2. And I have this whole thing to the half power. So that gives me, I guess I can write it as the square root of 25t squared minus 200t plus 625. And you can see that these are actually the same things because I've said here this is 2 d's, and d, of course, would be the square root of this. So I have 2d here, and I have 2d here, and I'm still trying to solve for the numerator. And again, I would still get the 4. So the closest approach happens at 4 hours, and I need to know what that closest approach is. So closest means I just need to substitute this 4 hours. So I'm going to say the distance, the closest approach, is going to be 25 times 4 squared minus 200 times 4 plus 625. And that gives you, it works out really nicely. It ends up being the square root of 225, which is 15. Now remember that distance is greater than 0 as well, so you don't have to worry about the negative. And then you'd have some sort of concluding statement. Therefore, the vessels, well, let's do it. The vessels are the closest at 4 hours, and that would be 15 kilometers. Okay, so that's not so bad. Once you've seen one, like I said, most of these questions, once you've seen how it all works, you're just finding the hypotenuse. Okay, let's go on to the second question. You are in a rowboat 2 kilometers from shore in a direct line when you suddenly have an urgent need to use the bathroom. The outhouse is 5 kilometers down the shoreline. You can row at 4 kilometers per hour and run at 7 kilometers an hour. Where should you aim to land along the shoreline to minimize the time to the outhouse? Okay, so I've drawn a little diagram here for you. So here's your rowboat, and this distance from here to the rowboat we said was 2 kilometers. And there's the outhouse here, 5 kilometers down the road. Now, these questions all work the same. It could be a question where you're going to go through a park and then down a road, and you can only go different speeds depending on the park. Maybe there's a lot of dog poop in it, so you got to be more careful, and then you can run faster on the road. Where should you aim along the shoreline to minimize your time? Okay, so we want to minimize time. And as you can see, all I've got here are distances, but I was given some speeds here. So minimize time. So that means we need to know how long are you going to row and how long are you going to run. Okay, so the key to doing these questions is to draw a line somewhere along the shoreline. Doesn't matter where you put it, it's all just so you can get the picture of what's happening here. Put a right angle in this triangle, call this length here x, and that allows you to label this length here as 5 kilometers minus x, right? So if this is x and this is 5 minus x. And this length here, you can figure out using Pythagorean theorem. So this is going to be the square root of 2 squared plus x squared, or 4 plus x squared. Okay, so now I've got my diagram set up, and I want to minimize time. So total time, total, is going to be time rowing, or time on the water, plus time running. Okay, so what is the time rowing? So you know that time is distance divided by speed gives you time, right? I went 400 kilometers at 100 kilometers an hour. It took me 4 hours. Okay, so I'm going to do the same thing here. These are the distances, right? We said this is distance. So rowing is going to be the square root of 4 plus x squared. And I'm going to divide that by the time, my speed of rowing. So that's 4. And the time running is going to be 5 minus x, and the speed I'm going at is 7. Okay, so before I start this, I want to straighten up all these radicals and simplify things a bit to make the derivative a lot easier. So if I pull out the quarter, so this is 1 over 4 times this, right? That's all that means. So I'm going to say this is 4 plus x squared to the half power. Okay? And then this next part here, this is 5 over 7 minus x over 7. So let's say 5 over 7 minus 1/7 x. Okay, so can you see how these are the very same thing? Of course you can. Okay, so now I'm all set to take the derivative. So t prime is going to be a half times a quarter is an eighth. I leave the inside alone. Chain rule here, right? Leave this alone. Reduce the exponent by 1 and multiply by the derivative of the inside. Okay, so I've got that part done. This is a constant. Derivative of any constant is 0. And the derivative of minus 1/7 x is minus 1/7. Okay, so I can straighten this up a little bit, right? Because it's just kind of messy again. So the 2 goes into the 8 4 times. That's in the denominator. Now remember, you have to be careful about what's on top and what's on the bottom. So what do I have left on the top here? I have an x, right? This x here. I have a 4 in the denominator, and this radical is also in the denominator. So the square root of 4 plus x squared. And minus 1/7. Okay, so now I can say for critical values, set t prime equal to 0. So I bring the 1/7 over here. So 1/7 is equal to x over 4 square root 4 plus x squared. And then I'm going to multiply, cross multiply. I'm going to put it over here a bit, which is not very nice format, but I'm kind of running out of room. So I have 7x is equal to 4 square root 4 plus x squared. And then, of course, now I want to simplify this. So if I divide by 4 and then square, so in other words, I'm going to do this like this. And I'm going to square both sides. Square both sides. So a lot of this work is just the mechanics of it, isn't it? So if I square both sides now, I'd have 7/4 squared is 49 over 16. X squared is equal to 4 plus x squared. So if I square a radical, I just throw away the radical signs, and there I go. And now I'm going to bring this x squared over here. So this is 16 over 16. So 49 minus 16, that's going to give me 33/16. X squared is equal to 4. And I'm running out of room again. And now I'm going to say x squared is equal to, can you see this? Okay, so I'm going to multiply by 16 over 33. So that's 64 over 33. And finally, x is equal to the square root of 64 over 33. And I also am going to say here that x is greater than 0. We can't have a negative length. And if you take the square root of that, you would get approximately 1.39. So you should aim for a point on the shoreline that's 1.39 kilometers from the line directly across from you, or you could say you could do 5 minus 1.39 and say you should end up a certain distance from the outhouse, or whatever 5 minus 1.39 is. It's like 3.61, right? Okay, so that's your rowboat maximizing or minimizing the time. Make sure you read the question to figure out what you're trying to minimize. And let's do one more here. Okay, so the last one is an electric utility company is required to run a cable. So this is a nice economics type application from a transformer station on the shore of the lake to an island. The island is 6 kilometers from the shore and the station is 12 kilometers down the shoreline from a point opposite the island. $4,000 on land, $5,000 under the water. Find the path for minimum installation cost. Okay, whoa. Sorry, I moved my chair, moved everything at the same time. Make you dizzy? Okay, so let's put some numbers on here. So this is 12 kilometers, this length here. The distance from the shore to the island is 6 kilometers. 6 kilometers. Okay, so just like the question we did, the previous question that we did, you're going to find a point on the shore and you're going to draw a triangle like this, make a right angle here. And of course in math we always assume everything's nice and flat and straight. So we label this X. So make X part of the triangle every time so that you can get an equation or a representation of how long this hypotenuse is. So this is just going to be 6 squared plus X squared. And this distance here now is going to be 12 minus X. Okay, so once you've done one, you can do them all. Okay, so a little different this time because we're trying to minimize cost. So I need an equation for the cost. So it's 4,000 on land. So my cost is going to be the cost on land plus the cost underwater, right? So you want to separate those underwater because you're multiplying by a different amount. Now this time we're not dividing, right? The last one, I don't know how many students I've had that have divided by the dollar amount because they divided on the other one. Just use your head. You divide because you had to find the time. You multiply. If I said it's going to cost me 4,000 kilometers and I went 2 kilometers, what's it going to cost me? You're not going to divide it. You're going to multiply, right? Okay, so the cost on land is going to be 12 minus X times the land cost, which is 4,000. Now I'm going to just put 4. I mean, at the end, I will know that it's in thousands, right? Or you can put 4,000 in. Oh, let's put the 4,000 in, but I wouldn't. It's just too many zeros. The cost under the water, the distance under the water times the cost, right? So that's 36 plus X squared. And we're going to multiply this by 5,000. So, like I said, you could have taken the zeros off and just say it's in thousands. Okay, so I'm going to expand and I'm going to simplify here. So I have 4 times 12 is 48,000 minus 4,000x. Now remember, I haven't taken the derivative yet. I'm just simplifying this. And 5,000 times the radical, well, I'm not going to change that. I'm just going to put this out front. And I'm going to write it like this. 36 plus x squared to the half power. Okay, so I'm all set to take the derivative. I'm going to call that c prime. Derivative of a constant is 0. The derivative of minus 4,000x is minus 4,000. And the derivative of this one, have to be a little more careful. A half times 5,000. Half of 5,000 is 2,500. I leave what's in the bracket alone and reduce the power by 1. And then I multiply by the derivative of the inside, which again is 2x. Okay, so now I have to simplify this. So I have minus 4,000, and this is going to be 5,000x, 5,000x, and this is in the denominator because it's a negative exponent, and I'm going to put it back in the radical form now that I've taken the derivative. Okay, so don't get all confused because you see all this kind of messy stuff. We're going to say for critical values, set C prime equal to 0. Remember, anytime you do something where you all of a sudden change an equation, you must explain. It's kind of math should be written out in a way so that anyone who is reading or looking at your work can understand why you did something. Okay, so now I've got it down to this point here, and I still have to solve for x, so I'm going to cross multiply. So that's going to give me 4,000 times square root of 36 plus x squared is equal to 5,000x. I'm going to divide by 1,000 here, so we can do this. That's why I said you didn't really need to do that. And then you can divide by 4. So I'm going to put the 4 here. I'm going to divide by 4. And then I'm going to square both sides. So that's going to give me 36 plus x squared is equal to, and I had 5 over 4. So that's 25 over 16x squared. And now I'm just going to finish this off nice and neatly. I'm going to multiply by, I'm going to subtract a 16 over 16. So 36 equals, when I say that, this is what I mean, right? 1 over is 16 over 16. So it's going to give me 9 over 16x squared. And then I'm going to multiply by 36 by 16 over 9, 9 over 4 is 64, right? So it's going to be 64 is equal to x squared. So, oh, this one divided out nicely, right? So x is equal to 8, x is greater than 0. So I'm not, again, putting in the negative. So that means you should go underground. Let's go back here. So I know my x is 8. So therefore, on land for x is 8, so 4 kilometers. And 4 kilometers on land times 4 times 4,000 is going to cost you $16,000 on land. And underwater, so I'm going to put in x's, what do we say, 8. So that's 16, 64, 100, square root of 100 is 10. So for 10 kilometers times 5,000 is going to give you 50, oh, there goes my pencil again, $50,000. And the total cost, it didn't say find the cost, but we'll do it anyway. So we got $66,000. Sounds like a bargain, doesn't it? Okay, so I hope that helped you. Make sure you understand all the different types of questions that can be asked of you for optimization questions. Once you've figured one out, I'm sure you'll find that the rest of them are pretty easy. If there's any questions in your textbook that you would like me to solve online for you, be more than happy to do that. Just leave me a comment below. And all the best. Hope this has helped.